This question is from physics chapter electric potential. In this question it is given that 4-point charges capital Q, small q and again capital Q and a small q are placed at the corner of a square of side A as shown in the figure. Here is the 4 charges present at the corner of it. Distance is A. We have to find the resultant electric force on the charge capital Q and the electric potential of this system. So let's try to solve the first part of the question. We have to find the force acting on any of the point of a capital Q. So let's focus on this capital Q, name it as A, this is B, here it is C and this is D. So at point P, we have three different forces acting on it. One is from AB, AD and then AC. So here we can make it as this is our force due to AB, here is the force due to AD and this is the force due to AC. We know that it's a square, so all sides are equal and this is 90 degree. If this diagonal bisects it, it means it is 45. This is 45. So here we can consider this is also 45, vertically opposite angle. So what is the component of FAC? It is equal to FAC cos 45 plus FAC sine 45. Cos 45 along x-axis, sine 45 along y-axis. So net force we have to find. So net force is equal to root of fx square plus fy square. So first we find the net force along the x-axis. So along the x-axis we have FAD and FAC cos 45. So we substitute it here, FAD plus FAC cos 45. Force formula is K Q1 Q2 by R square. This is the Coulomb force. So based on that, K, charge at A is capital Q, charge at D is a small q, and the distance between them is A square. Similarly, force at AC is equal to K capital Q, again capital Q, by this distance AC. So what is the value of this distance? So we know that this is a right angle triangle. We can say that A, D and C is a right angle triangle. This is A here, this is A here. So R is equal to root of A square plus A square. It's equal to root 2 A. So now we can substitute the value of the distance as root 2A whole square. Cos 45 is 1 by root 2. So it's equal to K capital Q, a small q by A square plus K Q square by 2 root 2 A square. Similarly, we need to find the value of Fy. It's equal to FAB plus FAC sine 45. So K, AB is equal to charge at A is capital Q and charge at B is a small q by distance is A square plus K capital Q a small q by root 2A whole square. Sine 45 is 1 by root 2. So further we will find it K capital Q a small q by A square plus K, this is capital Q here, Q square by 2 root 2 A square. This is the value of Fy. So we notice that Fx and Fy, both values are exactly same. So from that we can say that Fx is equal to Fy, and let's take it is equal to F. Now if we substitute the value of Fx and Xy here, so it is F square plus F square is equal to root 2 F. So now F net is equal to root 2 F, and F value we can substitute any Fx or Fy. So root 2 into K capital Q a small q by A square plus K Q square by 2 root 2 A square. Further, we can take common root 2 k capital Q by a square is common. We find it as a small q plus capital Q by 2 root 2. This also can be written as k capital Q by a square root 2q plus capital Q by 2. So this is the answer of the net force. We got it. Now in the second part, we need to find the potential energy of the system. So all the potential energies we have to find. So what is the total potential energy? Total potential energy will be the sum of all the individual potential energies. So here we can say potential energy of the system, it's equal to U is equal to UAB plus UBC plus UAC plus UAD plus UCD plus UBD. And the potential energy formula is equal to U is equal to K Q1 Q2 by R. So let's substitute the value. A and B, potential energy of the AB both has capital Q and a small q charge. So we substitute and the distance is A. So we can substitute as K capital Q a small q by A. Similarly, for BC, K capital Q a small q by A. UAC is equal to K Q into Q by root 2A plus K a small q capital Q by A plus K a small q capital Q by A plus K Q square by root 2A. Now you see these four are exactly same, so we can add all of it. So U is equal to 4 K a small q capital Q by A plus K Q square by root 2A and plus K capital Q square by root 2A. So from here we can say that U is equal to K by A bigger bracket 4 Q capital Q plus Q square plus capital Q square by root 2. So this is the answer of the second part of the question.